Hello, viewers. Today on 5 Minutes of Cloud, we're going to talk about how to save money in your cloud. A lot of people keep saying, I need to reduce the cost of my cloud infrastructure. How to actually talked on numerous occasions about the processes behind cloud cost management. But I wanted to see if I couldn't just in a couple of minutes go through what I think of as the key things that you have to put in place in order to truly save money with cloud. The number one thing right off the top is that you have to have an understanding of your cloud infrastructure. Now, if you've gotten a copy of our ebook, you'll know that we really think that tagging your resources is a critical component of understanding how your cloud costs, where those costs come from, what services do you have implemented, who's implementing them, what's in production, what's in development. Just being able to differentiate all those different resources is really a key critical aspect. On top of that, understanding how your applications are behaving. So once you actually get into production, understanding what actual production cost is the secondary thing that you can actually start to do. So beyond just tagging your resources, understanding how your application behaves is almost as important. I still think tagging is number one, just because without that, you don't know what's going on where, who's using what for what. Now, maybe you've named your instances in a certain way. Maybe you have some other processes in place. That's all tagging in my mind, is understanding what resources go where. So that's number one. Number two is understanding your platform. So this is where you get into observability. Now, there is a huge opportunity and a huge number of different components in an observability platform. You can look at just general services, what's being run, where is it being run, how long is it running, what kind of load is it under, so pulling in metrics against your application. You can also start getting deeper into the application itself, starting to look at latencies between client, so web browser, or maybe a static client, iPhone app, or something along those lines, going all the way into like the application itself, its internal processes, registry use, context switching within the application. Where can you put caching for data structures? There's a lot that you can do with observability, and it really goes across the entire world. I would say that the first level of observability that's critical, though, and the thing that's I think easiest to implement is just understanding the metrics of your application. So this is classically, like in a Kubernetes world now, this would probably be Prometheus. In any other environment, you'd be looking at an app dynamics, a Datadog, a New Relic, Wavefront. I mean, that there are a lot of players in this space, and I by no means am saying that I'm an expert in all of them, but any one of them will give you information about how your application is running, what resources are being consumed, and in what fashion they're being consumed. Like I said, you can take any of those platforms and go a level deeper. The open tracing world has actually really exploded in the last number of years. And that's taking the concept of an application trace and providing an open source bent around it. The Cloud Native Computing Foundation has a really good set of tools that work across platforms. It's not just cloud native, it works just about anywhere to do tracing. That gets more and more invasive, and that you actually have to start implementing things within your application space. There's some tools that will let you do traces without any tweaks to your application, but it still requires some knowledge of how your application works, which pieces need to be updated, etc. So again, from the top down, we're talking about first of all tagging, understanding what applications are running, what resources are being consumed, who's consuming them, and and then we can get into observability. And to me, the number one observability value, especially for managing cloud cost, is your application metrics. Now, understanding what CPU load means against your application really gets into the minutia of it, and it's useful, but that's not really what we're looking for. We're looking to understand, is your system consuming all of the resources that are available to it? Because we want to get to the next level of cost management, and that is auto scaling. And in my mind, there are really two parts of auto scaling. There's auto scaling at what we think of as, or at least what I think of as, the virtual machine level, where we're kind of at the sort of the real coarse auto scaling. I need to turn a machine on or off. That kind of auto scaling is great. It has a number of integration issues with it, because you really have to have good tie into your load balancers so that you're not killing instances and therefore potentially killing end user sessions by scaling down. Or when you scale down, how do you actually get rid of long lived sessions, things like that. Those problems exist regardless of your actual auto scaling process. but auto scaling is an important aspect of this. And compute auto scaling is going to be the largest cost benefit, right? So if I can turn a compute resource on or off, that's where we're going to see the biggest benefit in most cases, because often that's what I'm really paying for. So if I'm running Kubernetes on top, I'm still going to be paying for compute instances under the covers. And there are a lot of good autoscalers that work with Kubernetes environments. Amazon even has one, of course, now I've forgotten the name off the top of my head, but Amazon has an autoscaler that works really well within the Amazon EKS environment, and it can be used in other environments as well, just not quite as efficient. Other platforms, Google, Azure, et cetera, have their own autoscaling components that build in, and that's the underlying instance, the virtual machine level autoscaling. The problem with virtual machine level autoscaling is that it is often slow. Even best case environments, you're talking about minutes to get a new instance online, get it mapped into the load balancer, get it mapped into the control plane so that it's actually able to scale, add container resources to the system. So auto scaling can be really powerful, but it's only one of many tools in the playbook. Now, where auto scaling gets really interesting is when we start talking about containerizing your application. So if your application is not containerized, you have to go through a process. So again, it gets a little bit invasive because you have to go through the process of containerizing your application and mapping it into some container control plane. Now, today, most people are going to go directly to Kubernetes. I think there are probably some other tools available as well that might be of interest, especially if you're, for example, fully into the Amazon community or the Google community or the Azure community in terms of your cloud provider. All three of those vendors have containerized management platforms of their own. And they often have much quicker spin up times on a per container basis. The extreme side of this is where you don't even have to manage the container itself. And that's the serverless or function as a service type platform. So Amazon Lambda is effectively a way to either containerize or just provide your application into the system. You still end up effectively containerizing it these days, to map it into an automation control. But again, it's a potential change to your control plane. I think if you haven't containerized, this is a thing you're going to have to do to really get the best benefit of cloud cost management, because with containers, you have the ability to turn processes on or off. And especially because the underlying infrastructure is going to have that process available, even though the container is effectively a separate entity, turning on a new container is a seconds operation in most cases, instead of a potentially minutes operation in the VM world. Right. So the two sort of can still work hand in hand. You do eventually run out of capacity. And so you will eventually want additional resources. But this is where, again, we come back to observability. So we have tagging, we have observability and understanding of metrics of your application, and we have containerization. And these three components map together. There is overhead in any of them. Tagging, you still have to tag things. You have to go back and find things that aren't tagged and add them into a tagged model. You have to define your taxonomy for what your tags mean. With observability, you have to at least start to collect metrics. Now, metrics are usually fairly simple in that you can collect metrics at the underlying compute level. You can often collect metrics at the containerized level, but then actually mapping them to application performance is a secondary effect that gets much more invasive in terms of application benefit, and the actual gross benefit is probably going to be somewhat reduced. If you understand that as the system scales, if your latency of your application goes up, that would be a secondary metric that you can collect. And that's actually a gross metric that's fairly simple to collect. So if you're collecting CPU utilization, if you're collecting application latency, those two signals are probably the primary ones that can help drive auto scaling. And again, if I'm going into auto scaling as the sort of the third aspect of this, auto scaling and containerization kind of go hand in hand. Simple auto scaling, in that it's probably something that you can do even if you haven't containerized your application, does work as long as you have observability to drive it. But even then, you have to understand the latencies involved, right? So if you're worried about your customers having any impact to their application, so for example, if your system gets overloaded and it takes minutes to turn on a new resource, this is where containerization can help basically smooth out that curve. You're still potentially going to get to a point, as I think we all want to get to that point, where we have so many users working in our platform that we need to have additional scale, and that's going to get paid for, of course, by the value that our users are deriving and therefore are paying us for. So the cost of additional resource is not necessarily a bad thing as long as it's mapped to the income and the revenue that's being generated by the platform, right? And we're talking about managing cost effectively for best value. This is really sort of the key, is understanding that. So again, we've talked about tagging, we've talked about observability, both the compute metrics, classic metrics like CPU and memory utilization. We add to that a simple thing like latency. You can go down a deep rabbit hole and potentially get really good knowledge about your application with things like open tracing, useful tools, but again, more at the edge, and probably are going to be providing you a couple percent of benefit instead of tens of percent of benefit in terms of cloud cost reduction. And then auto scaling, and with auto scaling, containerization and a container control plane. I sort of order these all in terms of level of complexity, level of effort required to really get into and drive them. But really, this is the crux of it: is if I really want to manage cost, I have to not understand how my application is working. The finer tuned I get in terms of my application functionality, the better. But it's only so far as that it actually provides real value, right? So that's our goal, is to make sure that we're providing real value in doing this work and doing this effort. And just anecdotally, the customers that I've worked with in the past that have really been successful at finding good cloud cost reductions, I'm talking on the order of 10 to 50% even. And actually, there's one case where I've seen almost 90% cost reduction over a number of years, over a number of major replatformings of their application. So some actual effort is involved in getting to that kind of a number. But even in those cases, it's coming from raw compute going to containerized application environments. Those sorts of models are possible in certain cases with the right level of scale. And here we're talking about tens or hundreds of virtual machines running, and therefore eventually thousands of containers running. So you really have to have the operational ability to handle a compute instance and compute environment at that level. But in those cases, often that's been an accreted environment where things have built up over time, multiple instances, multiple environments, multiple regions running, right? Huge scale of application consumption. So that sort of 90% reduction was through a number of different stages as the containerization process really took hold, and we were able to get to a containerized development and delivery environment, had huge benefits. So I say that containers are really a crux, or are really a key component in this environment, but there is overhead in containerizing an application. And we haven't even talked about sort of the rest of the edge system. So things like, how do you make sure that you're getting the best value for your database? How do you make sure you're getting the best value for the data that you're storing and where you're storing it? How do you get access to that data? But these are all, to me, much smaller, finer grained, 5-10% maybe at the top end benefits that you're going to get out of cost reduction when you're looking at your application scale. The biggest bulk of it is going to come from tagging your resources, observing your applications in order to be able to drive automation, and specifically auto scaling at the container level, and then at the compute level. And in that order, I think you get the best benefit for your cloud infrastructure and your cloud environments. Anyway, this has been Robert Starmer bringing you 5 Minutes of Cloud. Please, if you enjoyed this episode, don't forget to like it, subscribe, follow on whatever platform you're finding us on. We really enjoy talking to you about these things. And if you have questions, don't forget to leave a comment. We're happy to either provide another 5 Minutes of Cloud, or answer directly in the comments. We look forward to having a good and interesting conversation at any time. Thanks so much.